Hello everyone, this is Amir Yassin from Autodesk bringing you another tutorial series that I hope you will enjoy. In this 7-part tutorial, you'll learn to create and use normal maps to provide detail to objects without adding geometry. It's a technique essentially used in game production, but can be used in any situation that needs simplified geometry. Here, you use it to make an ionic column with less than 1,000 polys look like one that is made of 50,000 or more. Imagine the overhead you would save if you were building a temple or a structure that has 50 or 100 such columns. Open the file column start.max. It shows a Roman column in both high-res and low-res flavors. There are also some hidden components that you'll experiment with momentarily. To see the difference in geometry detail between the two columns, you can use Edge Faces mode, F4, for quick visual feedback. You can easily see how much denser the column on the left is. You can also rely on scene statistics by pressing 7 on the keyboard. This shows you data such as the total number of polys and verts in the scene, but you can set the statistics differently. Click the plus sign on the viewport label and choose Configure Viewports. In the Statistics tab, enable the option Total Plus Selection. As the name implies, this lets you see the statistics of the selected object as well as those of the entire scene. With that in hand, you can clearly see that the high-res column has an excess of 67,000 polys, whereas the low-poly column has less than 1,000. The trick, of course, is to make the simplified column look more like its sibling with the magic of normal maps. Before you work on the column, you'll take a look at a simpler example to learn how normal maps operate. Open the file named normalmapeffect.max you downloaded for this tutorial. A download link is available in the movie description to an archive zip file that contains all the asset files that you need to complete this tutorial. The scene is very straightforward and contains essentially boxes in addition to 2 detail elements. Before we get into normal maps, let's cover the concept of what a normal is in 3D software. A normal is basically an orientation vector. It specifies which direction a vertex or a face are looking so that the software knows how to illuminate them. In order to understand its concept better, select the box on the left, box 01, and add an Edit Mesh modifier. Go into Edge mode and select all the edges. Note the dotted diagonal edges that are displayed. You may need a slight pan for refresh. Make these edges visible so you can study the face normals better. Go into Face mode and enable Show Normals. Note what happens when you select one or more triangular faces. Blue vectors appear perpendicular to their respective faces. In 3ds Max, you can also study the normals on vertices. Switch to Vertex mode and make sure Show Normals is enabled. Select the vertex at the top of the box. Notice that this vertex has 3 normals shooting in 3 different directions. In a way, this is expected as this vertex is common to faces shooting normals in the 3 same directions, but there's more to it. Exit Subobject mode and deselect the box. Disable Edged Faces mode, F4, and note the hard line between one side and the next. This is happening because the 2 sides are on different smoothing groups. Try this for size. Go back into Face Subobject mode and select the 4 triangles that make the 2 sides of the box. Keep that F4 shortcut ready as you toggle in and out of Edged Faces mode. With the triangles selected, give them a common smoothing group, such as 30. Exit Subobject mode again, and this time, the lighting seems different as the hard edge is gone. So what happened? In order to understand it better, go back into Vertex mode and select the same vertex as before. In fact, it should already be selected, but contrary to a moment ago, this time it's showing only 2 vectors. One is displayed as before, but now you have a single normal in place of the 2 older ones. The new vector's position is averaged between the orientation of the top and side faces. When a vertex normal is averaged, the light spreads across the affected faces, illuminating them uniformly. So, these averaged vertex normals, which are controlled with smoothing groups, ensure how lighting affects the geometry of an object. The more vertices you have, the more faces you have, and the more normals you can adjust. In low poly modeling, you are restricted as vertex count, and therefore normals count, is usually kept to a minimum. So, instead of working at a vertex level, you generate normal maps to work at a pixel level. Exit subobject mode when done, and take a look at the box in the center. It is reasonably high-res, as seen from the additional edges it contains. The box on the right is far simpler. By using the high-res box and the two detail elements, you can extract a normal map that, when applied to the simple box on the right, would work wonders. This has already been done, and the end result can be seen by setting the view to use the Realistic Materials with Maps option. In this case, the normal map gives the illusion of geometry where no geometry actually exists. The front of the box is still a flat plane. To see it more clearly, take a look at this particular normal map in Photoshop. The normal map image is mostly blue, with very slight gradients on 5 of the faces of the box. What's more significant is the center square representing the front of the box. The two detail elements were used to create the multicolor information, basically telling 3ds Max to react differently at a pixel level. Each different color gives a very specific normal direction, and the lighting in 3ds Max reacts accordingly, even without the presence of geometry. Be aware that the viewing angle is important, and the model can look perfect from one angle and less than perfect from another. Viewing the front from a parallel angle doesn't have the same effect as from a perpendicular one. You'll also notice that the detail elements were all curved or beveled. This is important, as you want to prevent any geometry that has parallel faces to the normal map projection. When you create a normal map, projected rays read the high poly geometry, and when the projected rays hit a surface, they analyze the angle and return a normal map value. If that surface is parallel to the rays, the projected rays will have a hard time determining a proper normal map value. This results in problem areas that can be very dark. This is something you want to keep in mind when you're building geometry by avoiding harsh angles. So, while detailed geometry will always give you the best results, normal maps can be a nice alternative at a fraction of the overhead cost. A typical workflow for creating normal maps goes as follows. First, you block out the volumes for the object you are planning to build, an ionic column in this tutorial. You then start detailing the high-res model, or models, that make the column. Once the high-res models are in place, you use them to extract a low-poly model. You then assign proper face IDs and smoothing groups to the low-poly object. You unwrap the low-poly object properly, so you don't have to rely on unreliable automatic unwrapping. Finally, use render to texture to project the high poly models onto the low poly column and extract the normal map. Once that's done, you create and apply the proper material with the generated normal bump map on the low poly model. This is the workflow you'll be following in this tutorial, starting with the next movie.